Hmm. Is that internet?
Okay. So I think we have started uh, randomized design, randomized, randomized design. Okay. The
Mm-hmm.
previous class that we have taken. Okay. Okay. So once we'll discuss, uh, first of all, complete randomized designing is there. So what is complete randomized designing? The diagram in figure 4.1 represents the details of the caffeine experiment, random assignment, the sizes of the groups and which treatment they receive and the response variable. So this type of design is called a complete random design. So what is telling? So what is telling that what is a complete randomized design? So we take 20 volunteer students. These are our experimental units, or as they are students, so we can say our subject. Then what do? We just random assignment. We just randomly assigned a task. For which task? So group one, we have taken 10 students, and group two, we have formed two groups. So group one, 10 students, group two, 10 students. Okay, now what we are doing? It is a caffeine treatment. Yes or no? Caffeine treatment.
Yeah.
So we one group will be a group which will have an active ingredients and one will be a non-active ingredients. And the group which have non-active ingredients is called as placebo effect. Correct? So placebo,
Mm-hmm.
so it is caffeine and non-caffeine. Then compare change in pulse rate. So now what we'll do complete. Compare the change in pulse rate. So what we have done, we have made two groups and then two treatments on two groups, and then what we are doing, we are comparing the output of it, comparing the changes between these two. So what we have used for assigning all the things, it's random assignment. So it is known as randomized design. So how we have conducted the experiment, generally what we are trying to learn here is how to conduct an experiment and how to go on in an experiment. What different steps we can take in an experiment and conduct the experiment in different ways, so that our output is the best and accurate for our further decision. So that's a completely randomized design. What was previous? I think it was replication. I have explained you. Replication is what we do an experiment repeatedly so that all the subject gets equal chances and get equally selected. Okay. So what is a complete randomized design? In a complete randomized design, the experimental units are assigned to the treatment completely at random. Okay. Completely randomized design. Add your word completely, completely, completely. Okay. What is the definition? You can note it here. Take this. That's completely randomized design. Means what? When all the experimental units are assigned the treatments completely at random. The treatment was completely assigned at random as we had chosen the two groups randomly. Yes or no, say? That's the thing. Okay.
Mm-hmm.
Now, what's the next thing? So you can read the text given below. So I think you have completed this. We'll read it once. Come on,
Mm-hmm.
chalo. Conclusion related measures improved in the high school football players who drank new chocolate milk, announced a recent headline. In the study, researchers compared a group of concussed football players given a new type of chocolate milk with a group of concussed football players who received no treatment. Explain why it is reasonable to conclude that the new type of chocolate milk is effective for treating high school football players with concussion based on this study. To test the effectiveness, explain why it is reasonable. So what is the reason he is giving? It is possible that a group who received the new type of chocolate milk improved because they knew they were being treated and expected to get better, not because of new chocolate milk. But new chocolate milk doesn't contain anything that their energy or their willpower increased while playing, but they thought that they were given special treatment, so they give their best in the game. That's the reason he's telling us. So to test the effectiveness of the new type of chocolate milk, you recruit 50 high school football players who suffered a concussion in the previous 24 hours to participate in an experiment. Write a few sentences describing a complete randomized design of this experiment. So just you have to write a few sentences. So what we'll do, take 50 high school football players, distribute it into two groups. Yes or no? How we have done it here. Distribute into randomly assignment by doing randomized assignment. We'll distribute these 50 students into two groups, 25 in one and 25 in other. Now what we will do, we'll give first group the chocolate milk and the other also the chocolate milk but without ingredients. So number the players from 1 to 50, use a random number generator to produce 25 different integers from 1 to 50 and give new type of chocolate milk to players with these numbers. Give regular chocolate milk to the remaining 25 players. So group 1 you will give the new chocolate milk and group 2 you will give the old chocolate milk that used to be given to the players. So compare the conclusions related measures for the two groups. Is this paragraph clear? This is the B answer is very important. How we are conducting the complete randomized experiment. Is it clear, Zaid?
Mm-hmm.
It is same as
Yeah.
this what we have done here. We can make a chart also of this. He has told us to write this sentence, but what we can do, we can make a chart also. 50 students were there. 50, 50 students. Okay. Then we do a random assignment or random experiment we have done. So we have got group 1 as 25 students and group 2 as 25 students.
Mm-hmm.
Correct. So now group 1 will get a regular chocolate milk and this one they'll get a new chocolate milk. Okay. Then what we'll do, how was it? We have chocolate milk and compare. What we'll do within the end, we'll I want to compare the conclusion of the result. Compare the conclusion of both treatments. Of both treatments. Is it clear? That was the thing. Is it clear, Zaid? Full? Okay.
Yeah.
Yeah. So that's easy and that's interesting too because these techniques will be required when you are doing an experiment in statistics. These all techniques are required and you should be what you'll explainable to the person who is what you will say correcting your experiment. He'll ask you different techniques that you have used while doing this. Okay, so you should remember you this theoretical chapter, this samples and survey. You should remember all the terminologies that are here in this. Likewise, the placebo effect, what we have learned in the starting is the different sampling, voluntary sampling, convenience sampling, then stratified sampling, random sampling, cluster sampling, what, why, when is what is preferable to us, what are the different stratified that you can use. Then in this we have learned placebo effect, control group you have learned, what is control group they can ask, when to use control group. These are the different questions that they'll ask in this chapter because this all thing is theoretical. You don't have to draw anything, you don't have to calculate anything. What you have to do is just remember the terminologies, what word represents what. Okay, is it clear? Okay, so now it's randomized block design. Completely randomized design are simplest statistical design for experiments. So completely randomized design, what are they? They are the simplest statistical design. We are learning the statistical design. So what we have first learned, complete randomized design. So it is the simplest one. They illustrate correctly the principles of comparison, random assignment, control and replication. Means in that we have done all the three. What we have done, first of all, comparing. We are comparing the output. Yes or no? Then how we are
Mm-hmm.
giving treatments, we are we are doing the random assignment with the experimental units. Then what third thing we are doing? We are controlling. We are control. We have learned the definition of control. What is the definition of control? Control means that we just concentrate on one exploratory variable and keep all the other exploratory variable at constant. Yes or no? That was the meaning of control. Correct? So we are doing control here also. Have we discussed here any other issue in the chocolate milk? No. Any other exploratory variable? No. Why we have not discussed here other exploratory variable? Because we are doing complete randomized design, and completely randomized design uses the concept of control and control group. Is it clear? So we have used control also here. And replication. Replication means what? We will be conducting different experiments with different, as we have randomly assigned students, we can again randomly assign students in the next task and give them again the treatment and then compare also. That's called replication. But just as with sampling, there are times when the simplest method doesn't yield. So this completely randomized design doesn't yield the most precise result when a population consists of groups of individuals that are similar within but different between. So when there is a similarity, when there is a similarity within, similarity within, similarity within but different between. So completely randomized design is not suitable. Completely randomized design is not suitable. Likewise, we have seen that for a very large population, random sampling was not suitable. So we came on to stratified. That's the reason the same thing is here. So it is not suitable. See here, see, he is telling a stratified random sample gives a better estimate than a simple random sample. We have seen now. See, I have not read it further, but I remembered the thing that we have studied there. I have not read this further previously, but I just read it now after telling you that I remember that when we were studying sampling method, so I remember that simple random sampling was very difficult when there was a large population. Correct. So for better estimation, what did we use? A stratified random sample we have learned. He is also stating that only. So these are all things that we can correlate and learn it. So this same logic applies in experiments also. So that was sampling and this is experiment. So suppose that a mobile phone company is considering two different keyboard designs, A and B, for its new smartphone. The company decides to perform an experiment to compare the two keyboards using a group of 10 volunteers. So now what we are doing, we are implementing a keyboard in a smartphone. So now we are doing an experiment on 10 volunteers. So the response variable is typing speed measured in words per minute. So what we have to measure is the typing speed of both the keyboards. Which keyboard fits the best, either A or the B. So how should the company address the fact that four of the volunteers already use a smartphone, whereas the remaining volunteers do not? So what is the similarity between the 10 volunteers now? 10 volunteers. So there is a similarity and also a difference also. So what is the similarity? That four of them previously used a smartphone. Previously used a smartphone. Smartphone. And six of them, the left six, didn't use. Okay. So volunteers use a smartphone, whereas the remaining volunteers do not. They could use a completely randomized design and hope that the random experiment. So see, you must have experience when you were a kid, and when you have first used a computer or a personal or a laptop, and the keyboard that you has used in it, you were using it very slowly because previously you have not worked with it. Yes or no, say? But when you are used to it and a new laptop also comes with you, you will use with the same speed as you are using your previous laptop, because you are used to it, because you are used to it, means you have a great practice of using it. So if I will take all the 10 volunteers in my one experiment, so my output will not be correct, because 4 of them have some similar things and 6 do not. So there is a difference between them. What is the difference? The difference is that they do not have the same thing or the same capability of using it. Is it clear?
Mm-hmm.
Yeah, just give me a minute and read this. Okay. So, how should the company address the fact? Okay, I'm back, Zay. So,
Mm-hmm.
so they could use a completely randomized design and hope that a random assignment distributes the smartphone users and the not smartphone users about evenly between the groups using keyboard A and keyboard B using keyboard B. Even so, there might be a lot of variability in the typing speed within both the treatment groups. Yes or no? If, for example, uh, I'm making two groups of five students of 10 volunteers, and this four who don't know how to use a smartphone fall in this group. So it is eventual that the typing speed here would be less. Typing speed would be less. And because four of them here does not know how to type and only one know how to type, so his speed will be much more. But this four volunteer speed will affect the average speed of all the volunteers, and here it will be more. So there is a very high variability between the two groups. That's the reason. So what we'll do now? Okay, so even so there might be a lot of variability in typing speed within both treatment groups, because some members of each treatment groups are more familiar with smartphones than the others. This additional variability might make it difficult to detect a differentness in effectiveness of the two keyboard. What should the researchers do? So now we come on to our new topic, that's the randomized block design. So first what we'll learn what is a block, and then we'll go on to what is randomized block design. So because the companies know that the experience with smartphone will affect typing speed, they could start by separating the volunteers into two groups, one with experienced smartphone users and one with inexperienced smartphone users. So we'll not just do randomized assignment. Now in this now in this now here we cannot do random assignment of students in a particular group in a particular group in a
Yes.
particular group, because we have seen that what is happening, because we are doing randomized assignment, it can happen that four students for which who don't know typing, don't don't know typing, fall in one group. So it will affect the speed. So what we have done, uh, will affect typing speed. They could start by the volunteers in the two groups, one with experienced smartphone and one with inexperienced. So we'll distribute the 10 volunteers into two groups. That's four with not unexperienced, and four with
Mm-hmm.
six. The left six with experienced. Okay. So inexperienced. Each of these groups of similar subjects. So what is here? We have made the subject similar. Similar subjects. Similar subject. What is the subject similar here? That they are unexperienced. And what is the subject similar here? That they are experienced of using a smartphone. Similar subject
Yeah.
is experience. Experience. Okay. So this is known as a that block one, and this is block 2. Because what we have seen here, I have written a definition above and I have not explained it, because it was been coming down. Like, see, when there is a similarity within, there is a similarity. What is the similarity between them? That the block one, all the 4 volunteers knows how to type and their experience. But difference also is there. But there is some difference between. So what is the difference between the two blocks? That one is experienced and one is unexperienced. Is it clear? This block
Yeah, it's
designing?
clear.
Yeah, it's very simple. So each of these groups of similar subjects is known as block. Within each block, the company could then randomly assign half of the subjects to use keyboard A and the other half to use keyboard B. So now what we'll do, this is a very good technique. So now with this 4, this is block 1. Now I'll distribute this block 1 into 2 parts. Likewise, for example, I'll randomly assign. So there will be 2 groups in block 1. Group 1 and group 2 with equal students. So there are 4. So we'll distribute it to 2 and 2. One will give keyboard A and the other will give keyboard B. Then the same as when what we have learned in the completely randomized assignment. Now we'll do the, after giving them the treatment, this is the treatment. So now we'll compare the result. Compare the results. Now in this, what we'll do in block 2, again we'll distribute it into 2, group 1 G1 and G2 with 3 and 3. Now we'll give them the treatment, both of them, that's keyboard A and keyboard B. Then what we'll do, we'll compare the result. Compare the result, which keyboard is better, either keyboard A or keyboard B. Is it clear, right?
Mm-hmm.
Yeah, so to control other variables, each subject should be given the same passage to type while in a quiet room with no distraction. So we have used control also here. What is a control? In which we keep all the other exploratory variable constant or fixed. The other exploratory variable does not change. So this randomized block design, block design helps account for variation in typing speed that is due to experience with smartphone. So you can, we'll take on the definition. I've explained you all the things, by the way, but we'll just put on the definition on our board. Okay. So what is a block? A block is a group experimental unit that are known before the treatment to be similar. So a block is a group which have similarity. Block have similarities. You can remember it likewise here. Similarities. Okay. In some way that is expected to affect the response to the treatments. In a randomized block design, all the things are similar. In the completely randomized design and randomized block design, all the things are similar. Just one step that we have added in the first step is that we have to distribute our, what you will say, experimental units into either 2 or 3 blocks with similarities. Is it clear, Zach? So that's called as
Mm-hmm.
randomized block design. Okay. Then we distribute the random assignment of experimental units to treatment is carried out separately within each block. After dividing the block, on block we do completely randomized design. That's the thing. Okay. Now next. So there is an example. Uh, Figure 4.2 outlines the randomized block design for the smartphone experiment. The subjects are first separated into blocks based on their experience with smartphones. Then the 2 treatments are randomly assigned within each block. Okay, so the 10, see what I have done, that's the same thing. Yes or no, Zaid?
Mm-hmm.
We can also draw this. Wait, I'll also do it. Wait, we'll draw them. Then 10 volunteers we have. I've distributed into 2. That's 4 and 6. This is B1. This is B2. Correct? Then what we'll do? We'll
Mm-hmm.
do random assignment. Random assignment on this now. We'll perform completely randomized design first year. So it will be G1 and G2. G2 with 2. G1 has 2 volunteers, 2 volunteers, and G2 also has 2 volunteers. So in G1, what treatment will give to them? That the year it will be keyboard A and year will be keyboard B. Now what we'll do in the last step, what
Mm-hmm.
we do? Compare the results. Compare the results. Is it clear, Zaid? The second one, I
Yeah.
hope that you will do it as a homework for this sixth one. Is it clear?
Yeah.
Yeah, that's simple. Yeah. So using a randomized block designs allows us to account for the variation in the response that is due to blocking variable of the smartphone experience. This makes it easier to determine if one treatment is really more effective than the other. To see how blocking helps, let's look at the result of the smartphone experiment. In block of 4 smartphone users, 2 are randomly assigned to use keyboard A, and it is all the description that we have done here. So here he has given the what you will say dot plot of keyboard A versus keyboard B. See, first of all, these are for example, for say, these were the two volunteers who didn't know to use the keyboard. So this type of dot plot we have learned just one scale, and we have plotted 2 dot plot. Yes or no? So you can see
Mm-hmm.
typing speed where it is the less from the dot plot. You can directly tell me where they have taken less time, either in keyboard A or keyboard B. What is our effectiveness when
I
we
took
are
less
testing a
time
keyboard?
for the B than A. A is faster.
A is faster, A, or B is
Yeah,
faster
A
than
is faster, B is slower.
B is slower.
Yeah.
It is word per minute. If I have 15 word per, yeah, A is faster and B is slower. Okay. So that's word per minute. So there is some evidence that keyboard A results in higher typing speed, but evidence isn't that convincing. Enough overlap occurs in the two distributions that the differences might simply be due to chances variation in the random assignment. So what we'll do, we have learned in dot plot how to distribute the parameters or our sample. So what we have done, see, we have done the 2 students in red who didn't knew how to use the smartphone. Then we'll compare, and in both the comparison you see that keyboard A is more efficient with the speed. Yes or no? Yeah. So now the overlap in the first set of dot plots were due almost entirely to variation in smartphone experience. Smartphone users were generally faster than non-smartphone users, regardlessly of which keyboard they use. In fact, the average typing speed of the smartphone users was 40, while the average typing speed for non-smartphone users were only 26, a difference of 14 words per minute. To account for variation created by the difference in the smartphone experience, let's subtract 14 from each of the typing speed in the block of smartphone using to even the playing field. Here are the results. So what we have done generally, where the speed was here, the average speed here in the red one, it was 26, and in the blue one, it was 40. Here also it was 40. Here it was 26. So what we have done, we have minus 40 from all these plots. So what
Mm-hmm.
happened? They will be overlapping each other. See here in this case, here it is here. That's the thing. So we have minus it because we accounted for the variation. Why we are doing this? To make the variation less, because data which is more variated or there are more variation is not considerable to be good for our prediction also and for conclusions also. So the variation in each of the distribution has been reduced. There is now much less overlap between the two distribution, meaning that the evidence is favor of keyword A is much more convincing. So therefore, after removing the variations also, again the keyboard A wins by a much bigger difference, so it is much more convincing. So we'll select keyboard A for our new smartphone which is to be launched. Is it clear how to do this experiment and how to randomly assign the blocks? Okay, now you have to give me this answer for this. Come on.
Mm, I guess the randomized block is design is
Yes,
the
describe a randomized block design for the experiment. Okay, we'll take this on our board. Take this on our board. Very interesting example, by the way.
yeah.
Okay. So a popcorn lover wants to determine if it is better to use popcorn button or her microwave. So generally I'll come on to the solution. So there are 40 bags, and here we are using randomized block design. So for what is the first step? To distribute into blocks. So how many different varieties are there, say, for the 40 bags
It's
that we have?
four.
Yeah, that's four.
Four.
So the based on the difference, we distribute the blocks. So there will be block one, block two, block three, and block four. So
So
there
the
are
blocks are the different kinds of popcorn bags.
yeah, blocks are the different kinds of popcorn bag. And in this popcorn bags, in one block there will be a similar popcorn bag. So in block one, what will be the butter one? Butter. There will be here it will be cheese. Here it will be what you'll say natural,
Natural.
and here it will be kettle corn. Kettle corn.
Mm-hmm.
Is it clear? This thing
Yeah.
here it is clear. So now 10 bags. So there are 10 bags. So here in block one there will be 10. Block 2 there will be 10. Here also it will be 10, and here also it will be 10. Now what we'll do generally,
Mm-hmm.
we'll apply, we'll now apply a random experiment. Yes or no? Random assignment. Random
Yeah.
assignment. After applying the random assignment, it will be distributed into two groups, G1 with 5 and G2 with 5. Yes or no?
Mm-hmm.
Same will go for both all the left three. So now we'll what we'll do, what experiment now we have to do. Okay, that's the main thing. Okay. So a popcorn lover wants to determine if it is better to use popcorn button on a microwave oven or to use the amount of time required. So there was two buttons in the machine, by the way. That one was using, we have put 5 bags using made the popcorn using the popcorn button. We made popcorn using popcorn button. Means when you press the popcorn button, it stops when the popcorns are ready by its machinery. When it seems that it is ready, it stops. And the second one was using, we made using timer button. Means what timer button means? We have set it an individual timer on it based on our experience. Timer button. Okay. So
Mm-hmm.
now what we'll do, we'll compare it. Yes or no, Zaid? The same thing
Yeah.
will be repeated for all the three. Yes or no? Same. This
Mm-hmm.
will be the same for all the three. That's the design for a random block experiment. Is it clear?
Yeah.
So you have to justify your choice of blocks. So what you have to justify, you have right that as there is difference between the popcorn bags based on their what you'll say varieties as butter cheese, natural, and kettle corn. So I have distributed as there is a difference. So therefore blocks are distributed based on the difference. So therefore I have choose block one as butter, block two as cheese, block three as natural, and block four as kettle corn. Is it clear, Jay?
Mm-hmm.
Okay, so explain why a randomized block design might be preferable to a completely randomized design for this experiment, and you know the answer. I have explained you with all the things, so we'll read it once. Okay, a randomized block design accounts for the variability in the number of unpopped kernels. Unpopped kernels mean the uncooked corns that were left when what you will say both of the both of these ways we have applied, one using popcorns and one using timer button. How much what you will say uncooked are left? Uncooked, we are measuring uncooked left in both the cases, uncooked left in both the cases, so we are measuring that. So created by different varieties of popcorn. It can happen that if we are taking completely randomized design, that butter cooks first, then what you will say cheese takes more time. It can happen. So their completely randomized design is not suitable. This makes it easier to determine if using a microwave button is more effective for reducing the number of uncooked unpopped kernels. Okay, that's the thing.
Mm-hmm.
Okay. Is it clear, Zaid? All the things?
Yeah.
Yeah. So
Mm-hmm.
another way to adjust the variability in unpopped kernels created by different varieties is to use only one variety of popcorn in the experiment. So we can, if we want to do completely randomized design, what we can do, delete all the three varieties and just use only one variety of popcorn in the experiment. Because variety of popcorn is no longer a variable. It will not be a source of variability. So if we delete all the three variety from the experiment, so there will be no need of doing a block design. Yes or no? it will be not a
Mm-hmm.
source of variability. Of course, this means that the result of the experiment only apply to that variety of popcorn, not ideal for popcorn lover in the example. That's the thing. So now we are on to the next topic, that matched pairs designs. I think it's the last topic of this section, matched pair design. Matched pair design. So what does it states? A matched pair design is a common experimental design for comparing two treatments that uses blocks of size 2. So it is generally used to compare two treatments that uses a block of size 2. Size is, how much is the size 2? Means in block there must only be two experimental units. That's the main thing here. In some match pair designs, two very similar experimental units are paired and the two treatments are randomly assigned within each pair. In other, each experimental unit receives both the treatment in the random order. Okay, suppose you want to investigate if listening to classical music while taking a math test affects performance. A total of 30 students in a math class volunteers to take part in the experiment. The difference in the mathematical ability among the volunteers is likely to create additional variations in the test. So, scores making it harder to see the effect of classical music. To account this variation, we could pair the students by their grade in the class. So, means what? For example, we are choosing 30 students. So, there will be more variability in the students, as there may be students who are good at maths, who are bad at maths. So, we'll compare the grades. For example, A grade students will be here, B grade will be here, and C grade will be here. All the three students, the students will be distributed on the basis of their grades. So we have used a block, correct?
Mm-hmm.
So the two students with the highest grade. Now in block 1 with grade, for suppose grade, the students who are getting grade A, grade B, and grade C. So in grade A, we have taken only two students from 30. Okay, from this two students, for example. How much we have to take in a matched pair design? Matched pair design has size of block only 2. The two students with highest grade are paired together. The two students with next highest grade are paired together, and so on. How much there are grades in the examination? So they are paired according to that. Is it clear? Two students. So are paired together
Mm-hmm.
and so on. Within each pair, one student is randomly assigned to take a math test while listening to a classical music, and the other member assigned to take a test without listening to a classical music. So in this two students, we randomly assigned, we do random assignment, and by random assignment, one student classical music, and one student, one student with non-classical music. So now we'll compare the results in each of the grades with grade A also, grade B also, and grade C and D, E. How much grades are there in the things? Is it clear, Zaid?
Yeah.
Sometimes each pair in a matched pair design consists of just one experimental unit. Sometimes it can happen that each block can contain one student only, or one experimental unit, or one subject in it. It can happen
Mm-hmm.
that get both the treatment in random. So if there is only one experimental unit in the block, so he only gets all the treatments at random. He only gets all the treatments. Suppose there are three treatments, so he'll get only all the treatments at random. So which treatment he gets first and which at second, it depends upon the random thing, which he will get first and which on the second. So in the experiment above, the effect of listening to classical music, we would have each students take a math test in both conditions. To decide the order, we might flip a coin for each student. Means what? Such that, for example, in this first student took non-classical music test, and the second one took classical music test. Now in the other case, what it will happen? In the second chance, this will give in a non-classical and this will give a classical music test. That is the thing. So now to decide the order, we might flip a coin. The order is decided on a flipping of a coin. If the coin lands on heads, the students take a math test with classical music playing today and a similar math test without music playing tomorrow. So we'll distribute the experiment in 2 days, today and tomorrow. If a person one gets a classical music math test with classical music on day one, so he'll get a math test with non-classical music on day two. Is it clear, Zaid, how we are doing all these things? Yeah. So this is a problem. A consumer organization wants to know if using a certain fuel additive increase the fuel efficiency of cars. A total of 20 cars of different types are available for testing. Design an experiment that use a match pair design to investigate this question. Explain your method of pairing. Just give me a minute, say.
Yeah.
Okay. So what we'll do, we have 20 cars. We have 20 cars. So depending on their, what you will say, mileage, you can say mileage also. For example, for a specific car, mileage is 20, mileage is 18, your mileage is 16. Okay, we'll design blocks. Okay, and in each block there will be two cars. Yes or no, say two cars. On then we'll do random assignment for day one. For day one. So for example, there will be one car and the other car. First car and the second car. Okay, and this two car random assignment for day two. Okay, day two. So here what it will happen, first car, second car. Okay, so what we'll do, second car, so here it will get the, what you'll say, what it was there, additive, uh, fuel with additive, fuel fuel with additive, and fuel without additive. Here also here now see, with additive he has got on the second day fuel without additive, and here with fuel with additive. Is it clear, Zaid, how to do it match pair design?
Yeah.
Yeah, it's simple, very simple. Yes. Okay. So we'll move further today. So okay, Alhamdulillah, we have completed with our section 4.2. So there is a summary of all the things, exploratory and response variable, our observational study and the experimental study. Then in experimental study, we have learned different terminologies, different things in that. So we are done with Alhamdulillah with section 4.2. Now in that section 4.2 in chapter, there is one more section, that's 4.3. What it is? Okay, using studies wisely. So we'll start this tomorrow. Is it clear?
Yeah, okay.
Okay. So we have Alhamdulillah finished with section 4.2. Today, inshallah, I'll forward you the second test. Okay. If you have time, give it today, or elsewise you can do it on Saturdays also. So I'll provide you with test on chapter 2 and chapter 3. You can do it on Saturdays and Sundays, then forward. Okay. Is it okay, Zaid?
Okay.
Yeah.
Yeah.
Assalamu alaikum. You can leave.
Alaikum salam.